All right. Hello, everybody. I believe we are currently live now, and my camera's not focusing. There we go. Hello. All right. Hello, everyone. Happy Friday. It is time for us to do a cool stuff live stream today. So that is what we are going to do. Um, let's see. I will just get started. Let's pull up the keynote and start talking about what we're going to talk about. Hello, Just Smile. Yes, we'll talk about what we're going to talk about, then we're going to talk about it, and then we're going to actually do it. So, how do I pop out the chat? There we go. Chat pop out. Let's do it. Where's the keynote? Keynote. There we go. All right. So, as usual, I'm going to give a short-ish presentation, bring on my guest. I've lost my YouTube preview, so that's cool. There it is. Okay. So I'm gonna bring on my guest, which is John this week, and then we're gonna hack on some stuff. And as usual, like if you have questions during my opening little short presentation here, like please put it in the chat. I'm happy to answer any questions. So yeah, let's get into it. Today we're gonna hack on optimizing method missing. Not specifically method missing, but you'll kind of see what I mean in a minute here. But first off, yes, happy Friday. Happy Friday, everyone. I am very, very happy to be here today. It's been a while since I've done a live stream, so it's good to be back. Um, Unfortunately, so I was supposed to do a live stream a couple weeks ago, but I was preparing to speak at Red Dot Ruby conference, and I just felt kind of stressed out, so I didn't want to do live stream plus prep for a conference, so I decided to push it out a couple weeks. So sorry I'm a little bit late, but it is what it is, and we're doing it now, so that's fine, right? So my guest this week, as I said before, my guest this week is John Hawthorne. I've had him on a few times before, but he's going to help me out today. And today we're going to be looking at delegate methods. I said method missing, but it's kind of related to method missing. You'll see why. You'll see why in a minute here. But we're going to talk about delegate methods and an optimization that we worked on that's already landed in Ruby 3.4. But we're going to try to apply that same optimization to method missing cases or cases similar to method missing. But first, I want to talk about what the delegate optimization is. Like we're going to do kind of a quick intro into what that optimization is, how it works, and then we're going to figure out how to apply that same optimization to method missing. So like I said, if you have any questions, like any questions at all during the presentation, put it into the chat. Happy to answer any questions you have as we go along. So when I say delegate methods, I'm talking about methods that look like this, where they just take a triple dot, like they take a triple dot parameter and then they pass that triple dot parameter on. And of course, that triple dot parameter means it takes any arguments and it passes all of the arguments that it received onto that next method. So we already have an optimization for this particular case in the master branch of Ruby, and we're going to go over what that optimization is. So here, like, I wanted to point out what the instruction sequences look like for this thing. Fabi is asking, is method missing better optimized these days? I thought it was always some kind of bottleneck. It is, in fact, a bottleneck. We'll see why in a minute here. And I think what we're going to try to do today is eliminate that bottleneck. I don't know that we can eliminate 100% of its overhead, but we can eliminate a lot of its overhead, and we're going to try working on that today. All right, so here we have compiled instruction sequences. Oh, you're Just Smile, you're welcome, and also I'm happy to have you here. It's great to have you on the live stream, and also make sure to ask questions if you have any. We're happy to have you in our community. Anyway, so here are the instruction sequences for this particular method. That top box is Ruby 3.3, and the bottom box is Ruby 3.4. And I want to point out the differences in the iseqs here. So the main differences you'll see is in Ruby 3.3, that method that we looked at earlier, the very simple delegate method, it takes three parameters. So you'll see here when we look at the disassembly, like it says that the parameters are the number of parameters are 3. Um, and in Ruby 3.4, there's only one parameter. So this is a huge, really big difference between the two. You'll also see here the actual body of the method. The instructions are a little bit different. Just looking at this, from a high level, you can see like just the number of instructions is fewer. There are fewer instructions in Ruby 3.4 than in 3.3. And we're going to walk through the differences here specifically. You'll see in Ruby 3.3, what we do here is we do a put self because self is the receiver. In this case, we were just delegating to some method. I should have put the code in here. Actually, let's just go back to the keynote back to the slide to refresh everybody. This is the particular compiled code that we're looking at. So it's this method that all it does is delegate off to a second method. So the instructions for that are: we put self onto the stack because the receiver is self. It's implied receiver. And this is specifically in Ruby 3.3. Then we say get local on this local variable called star. Then we say splat array on that thing, that star that we pushed onto the stack. Just Smile is asking a newbie question. Do you think in the future Ruby will reach the speed of compiled languages? I want to write only Ruby from now on. That's a good question. In some cases, absolutely, it will reach compiled speeds, or even I think that it can surpass them too, depending on the JIT compiler and the code that you're looking at. But yes, I think it's certainly possible. All right, so we splat an array out. We do a get block param proxy, and then we do a send. So these instructions are happening because in Ruby 3.3, these two methods are basically equivalent. In Ruby 3.3, triple dot syntax is just syntactic sugar for this second form that we're looking at here, where it's like, hey, I'm going to take an array of parameters and a block, and then basically we splat that array out, and then we call along with the block and pass it on. So these two are basically equivalent in Ruby 3.3. So what's going on here is the overhead of these delegate methods in 3.3 is because I'm going to walk through that overhead here. Also, I haven't practiced these slides at all. I just made them yesterday, so please forgive me for my lack of professional presentation here. All right, so before we actually call the foo method, this bar at the top is the stack. Yes, Chip says we'll do it live. We're absolutely doing it live here. Yes. So that list at the top is our stack. So those are the values that are on the stack, Ruby stack. So before we call into the foo method, we have the values 1 and 2 pushed onto the stack. So we push those onto the stack, and then as soon as we call into this method, we actually take those values and flush them out to an array. So they're removed from the stack and written into a Ruby array. And that's like, it's kind of understandable why this would happen when you know that this triple dot is just syntactic sugar for that splat case. Like the splat case, you would absolutely expect it to have converted your stack into an array because you have access to that array. So it flushes the stack to the array, and then when we call into bar here, it'll actually take that array, and then eventually it takes the elements in that array and then copies those elements onto the stack, and then it calls into the other method. In Ruby 3.4, the difference here is that rather than like evicting those values from the stack and converting them into an array, we actually leave them on the stack. So we just leave them there. We call into foo. We push an EP, which is the EP is basically our marker for where the new stack frame begins. So this EP is like, hey, I've entered a new function, basically. So this is kind of our marker for the function. Then when we call into bar, we actually take those values that were in front of the EP and we just copy them. We just do a mem copy into the new location, and then we call into bar. But there's kind of a problem here, which is like, how much stack do we actually copy? So you can see in this case, like if bar were to have default parameters, like x, we default x to 0 and y to 0, it means that when we call that delegate method, we could call it with 0, 1, or 2 parameters. So when we're calling into the bar method, like how do we know how much stack we need to copy? That's kind of a problem here. So like let's see. What was I going to say here? Yeah, so here, in this case, we have to copy 0 items. In this case, the second case, we have to copy 1 item. And in the third case, we have to copy 2 items before we call into the bar method. So how do we know, how much it is that we need to copy? Well, actually, we can know this. We can know this amount. This amount is known. And the amount is known actually at compile time. Like if we take a look at those 3 calls where we were calling foo with 0, 1, 2, or 3 parameters, and we disassemble that, we look at the bytecode for it, you can see the different calls here. So these are the different calls to the foo method. And interestingly, you can see here it has values. It says argc0, argc1, argc2. So the compiler actually knows what the stack size is before on entry to the foo method. So we have this information. It's just that when we do that delegation, we don't have access to it. So we need to provide access somehow. Interestingly, these call data, like this stuff that you're seeing here, these are all actually hidden Ruby objects. So these are all, like this data that you're seeing printed out here, these are Ruby objects. They're called call info objects, and they're just hidden Ruby objects. But since they're Ruby objects, it means we can pass them around like regular old Ruby objects. And these Ruby objects contain, like these objects contain like the method name, the stack size, and information about the parameters that we're passing as well, whether they were keyword arguments or whatever it is that we have. So we actually have all this information in a Ruby object that we can pass around. So the optimization that we worked on is, we need to figure out how much data we need to copy, and we have this hidden call info object at the call site that we care about. So in this case, we'll say, hey, we've got this hidden CI. It knows its argc is 2. So what we do is, before we call the foo method, before we enter the foo method, we take that object and we push that object onto the stack. So we push a reference to that object onto the stack here, and then we write our EP, and then before we call bar, we push a reference to that hidden CI object onto the stack. And now when we call into bar, we can take a look at that. We can take a look at that object and say, like, how much stack space do I need to copy from my caller? So it has that. We're able to take this CI object, pass it around, and that indicates how much stack space we need to call or copy. So we pop that value off. We know we need to copy 2 parameters because it was in that object. We copy the 2 parameters, and then we're able to call into our delegate method. So we can see this if we disassemble this new code. If we disassemble this method on Ruby 3.4, you'll see here that we say, hey, we're going to do this like get local triple dot. And that local value, that triple dot local, is actually our CI object. So we're getting our call info object, and then before we call this send forward instruction, like that call info object is on the stack. So we say, hey, get that call info object, push it onto the stack, and then the send forward instruction knows to read that value, read the stack size value from the CI object and copy it onto the stack. So this is how we can avoid allocating any arrays, and we know what type of parameters we need to, or how much stack space we need to copy, and the type of parameters that we're passing. All that information, we can pass it down the stack. So unfortunately, when I was working on this, I really wanted to keep what we were doing targeted, like very specific. Like I wanted to make sure that if I made any bugs or anything, that the blast radius was as small as possible. So we specifically only targeted triple dot methods, so methods that specifically only take triple dot and then pass on triple dot. So for example, like this top method is optimized where we have triple dot, but our bottom method is not optimized. So if we take a parameter as well as triple dot, that case does not have the optimization in it. Uh, so of course, a very common case for this is method missing, where you take a name and then you take like whatever the parameters were and you want to pass those parameters on. So like you care what the name of the method is, but you don't care what parameters were passed. So this is like a pretty common case. Um, Levian is asking, would CRuby not reuse the stack frame in the case of the delegate only method and function? No, it doesn't reuse. It doesn't reuse the stack frame. It pushes a new frame. So it pushes a new frame, and then it just copies the data from the caller frame into the callee frame. So that means like if you do puts caller, everything looks as you would expect. So let's see. If we take a look at method missing, so I implemented a very small method missing here just so we can take a look at the instructions. And this is actually on Ruby 3.4 currently. You can see, I'm not going to go through all the instructions, but you can see that they're very complicated. They're a lot longer than the previous examples we saw on Ruby 3.4. And it's because this is, again, syntactic sugar. It's just taking that star, like it's converting triple dot into a star, 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 ampersand, and then splatting all that garbage out onto the stack. So we get a lot of objects created here. What we would like it to look like is like this, where we just say, hey, we're going to get that triple dot, and we're going to pass that thing off. So unfortunately, there's kind of a challenge, which is local variable access. So I want to touch on local variable access and how that works and what the challenges are. So when we have a method that takes parameters like this, the parameters are treated just the same way as local variables. And the way local variables work is that each local variable is assigned a negative index. So in this case, we have two local variables, x and y. They're both assigned negative indices. So in this case, x would be assigned the value -2, y would be assigned the value -1. And these values are negative offsets from the EP. So they're relative to this EP value in the stack. So for example here, -1 indicates 5, so our value for y is 5. -2 is 4, so our value for x is 4. And the reason we do this is because we want to look up these local variables by index and not by name. If we had to look them up by name, we'd have to probably do like a hash lookup to get this index, and we want to get rid of that overhead, so we map all these local variables to indices. So in this case, we'll just do like get -2 plus get -1 in regard to offsets. So when we say get x, it looks at the negative value from the EP. When we say get y, it looks at the negative value from the EP and pushes those onto the stack. Oh man, I should have tested I did not test these. I didn't test these slides out. Oh goodness. Oh, there we go. Okay. So let's say we have a case like this where we're taking x and a triple dot, like a triple dot parameter. X is going to get assigned the value -2 for our local index, and triple dot is going to get assigned the value -1 for our index. So in this case, if we were to print out the value x, like what is it going to be? If we print it out this way, if x is -2, it's going to print out 5, which is incorrect. We would expect it to be 4 because x is supposed to be our first parameter. So we have a problem here. We can't assign x -2. It actually needs to be -3, or we need to do something else. I think my idea for a solution to this problem is that we want to take the leading parameters. So if we have one parameter, like in this case, we want to take those parameters and push them to, what would that be, the bottom of the stack? So we basically want to swap, in this case, swap 4 and 5. So we want to take the top end values, which would indicate those parameters. So if we had like 2, 3, 4 parameters, we would take those 2, 3, 4 parameters, put them onto the bottom of the stack, and then the rest of the stack slides up to the top, and then we're able to copy that into the callee. So in this case, we'd swap 4 and 5, and now x is assigned -2, triple dot is assigned -1, and we get the right values in this case. So -2, -1, x has the right value. In this case, it's 4, like we would expect. But we also have to do some extra bookkeeping when we call into our delegate method. because we don't want to copy the entire stack anymore. We just want to copy the stack minus the parameters. This is complicated and nobody has any questions. That is even confusing for me. Anyway, so our high level goal is that we want to take this stack and we want to rotate the stack by n, where n is the number of leading parameters to the method. And then when we delegate, yes, John. Okay, John, I will. Juan says, I don't want to think about the amount of time that goes into researching this. Yeah, I know, right? It was a lot of time. All right, so we want to rotate the stack by n, and then we want to copy, when we copy the parameters, we want to copy argc minus n into the stack. So like, yes, please review this later. I'm going to, let's see, Justin asks, this is a random question. Are you familiar with decorator functions in Python? I am not familiar with decorator functions in Python. I don't know them. Okay. So I'm gonna bring John on now, and then we're gonna talk about this, and then actually hack on it for a little bit. Let's see, dude. Hello, John.
Hello.
How are you?
Doing well.
Thanks for joining me on the live. I appreciate the collab.
Yeah, thanks for having me. Long time listener.
By the way, folks, if our audio levels aren't like good, let me know. I'll adjust the audio levels so they're more even. I haven't really tested them. Anyway, welcome on. Last time you were on, I think we were talking about like we were profiling stuff, right?
That sounds right. Yeah.
That's why I made your title "Profile of a Profiler." Anyway, how are you, and what questions do you have? Tell me.
Oh, how I vaguely remember some of this from when we worked on it, but
Yes.
how are we going to so we store the number of arguments we need to forward in the call info. If we're then extracting one of those arguments and then maybe putting it back in, how do we handle that?
Well, we know. Okay, so boy, maybe we should do code. Should we just go to code, and then we can talk about, like, it's probably easier to discuss this when we're just looking at a code example.
I think so.
Yeah, okay. All right. I'm going to take us to code, and then we'll discuss what's going on here. One sec. Send desktop. Okay, cool. Oh, that's weird. All right, so let's say we have a method that's like missing x comma triple dot. Okay, so you were asking what? How are we going to copy stuff? Oh, we should probably delegate to something else. Def, I don't know, bar, let's say a comma b, we'll say a plus b, and then let's do like,
okay.
I don't know. Let's just do this. Yeah?
Yeah.
So we'll say missing bar, and then just like 2 comma 3. Does that make sense?
That makes sense.
Okay. Someone's asking, Chip is asking, what takes longer, coming up with the delegate method optimization strategy or coming up with titles for guests? The optimization strategy is a lot harder, yes. Okay. So, we have, like, should we compare this with the original case?
What do you mean?
Like the no leading parameter case. I think we should compare this with no leading parameter case just to go over it.
Okay.
So
we could make 2 methods and call each of them. We could have like missing and found.
Ah, good idea. Yeah, 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 yeah. I like
Something like
that.
that.
Yeah, yeah. And then let's fix this.
Oh,
Okay, that looks good. So let's discuss found first.
Hmm.
So at the found call site, we know that the argc is 2 here. So our stack size is 2. Maybe it's more clear if I say like stack size is 2. So our stack size is 2 at this location. And we have that information in the call info object. So I'm gonna do like let's do ruby dump. Okay. What did we do wrong? This is fine, right? I thought this was fine.
What version of Ruby were you running?
Oh, right. Thank you. Good call. Okay, so actually, let's simplify this just so we can show this. I'm gonna comment all this stuff out. So we'll say found. We'll call found with 2 parameters, and when we look at this, we see right here, like right here, our argc is 2. So we know that the stack size, we know the amount we need to copy is 2. So that's like kind of what I was showing in the slides. Akshay is asking, I've always struggled reading a profiler flame graph chart. Can you recommend any good resource to learn or any interactive guide? I recommend the live stream that John and I did on profiling stuff. You should check that out. I'll see if I can find a link and put it in the show notes. But yeah, I recommend that.
My other advice is that reading profile data is hard, so don't be hard on yourself if it's tricky.
Yes. Okay, let's see. So we know it's 2 there, which means that when we call into found, we want to copy 2 items. So the problem is here, I think, John, what you were asking is, we know, like, here our stack size is 3.
Yeah.
So we know our stack size is 3 in this case. So when we enter missing, the stack size is 3. But here, when we call bar, we only want to copy 2 items. So how do we know, we pass down, we said like, hey, we're calling with 3, our stack size is 3. We want to make sure that we're only copying 2 items in this case rather than 3 items, right? So I did a little bit of homework before doing this live stream. So I have an answer for you. I was thinking, so we already have to take into account the parameter size. Like we need to know the parameter size. So I think what we can do is when we call into bar, we just say, hey, I'm going to copy the argc stack size minus the param size.
Like minus your own instruction sequence's lead
params. Exactly. Okay. Yes. So when Ruby compiles this, it stores the number of parameters on the method itself. So the method itself knows how many parameters it takes. John, your audio is a little janky.
Oh,
I'm gonna turn you up a little bit, maybe.
That doesn't sound great.
They say you sound like a robot. You don't sound like a robot for me. Say some test stuff, John.
Testing 1, 2, 3. I am a robot.
Audience, does he sound like a robot? Because I got good audio here. We gotta wait for the video lag, I guess. That's exactly what a robot would say. Okay, I don't know. Yeah, robot, but it's understand a little bit, but not horrible. I don't know. Like, what should we do? If I remove,
like, if it sounds okay for you, it must be like OBS.
I guess I could stop the stream. Okay, we're gonna carry on. All right. Let's see. Somebody says, so missing has a list of 1 parameters plus the argument. Yeah, exactly. Yeah, Juan says, so missing has a list of 1 parameters plus the argument. Yes, that is exactly the case. So, Juan is asking, what happens with named parameters and or blocks? Do they get stored in the same array before the EP, or are they stored in a separate map-like structure? That's a great question. We didn't cover that. I specifically didn't cover keyword arguments because it's like just an unnecessary complexity, I think. But I do have 2 audio streams listening to the call, I think. I got the one going out from OBS and then another one on the background for me to listen to. Maybe I can, well, I don't know what to do. Let's check Video Ninja. I'm gonna maybe try mute you and then unmuting you.
Okay.
Okay, I tried that. I don't know if it does anything.
Yeah.
All right. Anyway, so with regard to keyword parameters, they're also pushed on the stack the same way that positional parameters are. So we don't really have to worry about that too much. The callee basically does the reordering. It figures out where all those parameters go. So we don't need to think about it too much here. It's not going to impact us. Okay. So back to this. We know we have one lead parameter. So really what we want to do is we want to copy three items minus number of lead params. Does that make sense?
Yeah, that makes sense.
Okay. I hope your audio is not.
I hope it's not too bad.
Hopefully not. Can I like? Well, I don't know. Should I remove you and add you again? I don't know.
That's probably worth trying.
Okay, I'll try it. I'm gonna remove you. Let's see.
Oh, I know what it is. Do I know what it is?
I refreshed you. Maybe it's better now. Oh, that fixed it? Say some stuff, John.
Okay. Hopefully that's fixed. So I do know one thing that messes up audio, which is the Mac OS mic mode feature, the thing where it does like voice isolation. If that ends up happening, it's bad. But I am not using that.
Okay. Well, folks in the chat are saying it's fixed, so I'm gonna believe it's fixed, and let's move on with our lives. All right. So we want to copy 3 items minus the number of lead parameters. I think that's what we're gonna do. Does that make sense? So here, and the algorithm is exactly the same here. In this case, we copy 2 parameters minus the number of lead parameters, which in this case is 0. So it's two parameters. All right. Okay, cool. So I did a little bit of homework before this. I wish I could use Command K in Tmux, but I cannot. It does not work very well. So like, I want to show. Let's just do this case. I want to simplify this a little bit. I'm going to remove the if statement. Right. So we're just gonna, in this case, we're gonna take X, but we're just gonna ignore it, and then pass on the next 2 parameters. I want to simplify this even more, just to demonstrate a strange thing. So I was mentioning in the presentation that like this triple dot syntax is a syntactic sugar for star amp thing. And we can actually see that if we look at this is like, personally I find this to be a little bit unfortunate, is that we can actually see that if we look at the AST, like it's done at the AST level. So if I do Ruby, this is actually, let's do Ruby 3.3. So here we have our like really basic method missing thing. If I do ruby dash dash dump equals parse tree test.rb, if you look at the AST for this thing, you can see right here. If you're not familiar with the AST, it might be a little bit harder to read, but like you can see right here, we've actually expanded it to a star and then an ampersand. You can see like right there as well, we have these parameters, which like was not in my source code. So
yeah, for me, the really odd thing about it is not only is the star and ampersand there, which I could sort of see getting automatically converted, but also the triple dot.
Yeah. That's funny. It is, yes, there's a triple dot. There's also a triple dot right there. And if we actually, let's go to Ruby master. Oh, RoboJohn is back. Oh no, jeez. I'm gonna refresh you again. We'll see if that does anything. Bye, John. Now you're back. Hello.
Hello.
Let's see if that fixes it. So if we do like, on Ruby master, so Ruby master, this is before any changes. If we dump the parse tree here, it's actually a little bit worse, I guess. It's like star, ampersand, triple dot. So we got like, what is that? 1, 2, 3, 4, 5 parameters. And then here, like, here's our triple dot where we're passing it on. So like, it's not great. But what I have done, since I don't really want to deal with it, like, I don't think folks in the live stream are particularly interested in fixing the parser because it's not fun.
And we have to do everything twice.
Yes, we have to do everything twice. I already fixed it here, so it's already fixed here. If we do mini ruby dash dump equals parse tree test.rb, I've eliminated that, so we don't need to worry about it. Like, we don't need to worry about it here. In my branch, it's just _x and the triple dot, and then you can see we're just passing triple dot on here, so we don't need to worry about that in our branch. All we need to worry about is making sure that the stack is like correct, and then yeah. So I figured that would be more interesting for the live stream. Plus, like, we don't have that long. I feel like an hour, especially when you're having a yap session. An hour is not that long.
No. We can accomplish something.
Yes. Yeah. I'm learning more words from TikTok. Okay. All right. Let's see. So we're gonna do this. What do we need to do? Where should we start? I know where we should start.
Okay.
Let's take a look at the code that actually copies the stack to the callee, from the caller to the callee. That makes sense?
Do we okay. The parser is the parser gonna emit the code for us to actually be able to test this?
Yes.
Okay, great.
Yeah. Actually, I think let's I think it will right now. Let's
or the compiler.
I think the compiler will emit the correct code. Let's look. Yeah.
Great.
Yeah. So I also did a little bit more homework here. Let's spread this out. Look at that.
Oh.
There we go. Yeah, so what John is asking is, will the compiler emit the right code where we just want to get like the triple dot and then pass that down, and we do here. So this is it. We're getting that hidden CI object, and then we're doing a send forward instruction right there. So we have all the stuff in place, like the compiler is emitting the right stuff, the parser is giving us the right stuff, but we're not doing the stack is not going to be correct. And I think I put like a crash in there right now. So if we call this, I think it'll blow up. Let's just run it. Or not. Okay. That's weird. Huh. We get an argument error?
Yeah, that's sort of impressive for a method that doesn't exist.
Yeah. Missing?
Maybe it's just in. Is it just in the call to missing?
It's got to be just the call missing. One lead parameter, stack size 3. I wonder if we're giving the wrong... I don't know. Let's try to figure it out. Wrong. Why would it give us wrong argument? Wrong number of arguments. That's like odd. Should take PTO every time. Yes. Okay. What do you think? What should we do, John?
Well, we should probably try to fix it. So, well, I'm just trying to figure out what's going on. So here's where we call missing with argc3.
Yep.
And then missing is defined as, well, it is defined as something that takes only one argument. It's argc1.
Ah, I know what the problem is.
Okay.
I think. So I added a new thing to the debug output, and that's whether or not the iSeek is tagged as forwardable. So this, if you look at that, like the local table, do you see the local table
It says
code?
forward 0.
Yeah, forward 0. So it seems like we're not tagging this one correctly, I guess. So let's figure that out. Where did I do that? So we need the flag forwardable to be set to true in this case, and for some reason it's not being set to true on this iSeek. Okay, so I guess that would be done in the compiler. Let's find that. Let's find where we do it otherwise. Okay. Looks like this is the only case. I think this if statement is probably wrong.
Yeah, well, the comment suggests it does not what we want it to.
Yeah, exactly. Drew is asking, does Ruby master run it okay? I'm pretty sure it does.
Yeah, it won't. It's only your branch that's trying to apply this optimization.
Yes. So I think this is the problem right here. Args. So if args is forwarding and our pre-args num is 0, which is probably not the case here. I think we have more than one arg. And there's no optional args. I think we just want to get rid of like this. This equals 0, I think. It's probably good enough.
Yeah, because we're just trying to support having arguments.
Yes. We'll give that a whirl. And I think that this is like not...
That's probably
I think this is impossible. It would be.
Are you not allowed to have optional arguments and triple dot?
I don't
think
so.
That kind of makes sense because... Yeah.
Let's try this. Okay, so we'll run this. Ah, yeah, look at that. Forward 1. Great.
Nice.
Nice. Does it work though? Like, can we call it? Hey, that's great. So we're able to call this, and then let's like try returning something. Let's make sure. Yeah, nice. Okay, so we got that, but I'm guessing X is wrong?
Yeah.
So if we print out X should be bar, but I'm guessing it's gonna be 3. Oh wait, let's just return X. It's gonna be a crash. What is the crash? You know what the crash is? I bet the crash is my fix me comment. No, it's straight up busted.
Oh, but it's a segmentation fault inside inspect, so we're trying to inspect some sort of object that is broken in some way.
Yeah. Okay, let's do this. Let's do I want to see what the instruction sequences look like. Okay, so it's... Well, that's wrong. No, that's not wrong. X at 0? Yeah. That's correct. Looks right. Yeah?
It looks right, but we might have the wrong thing at that index.
Yeah. Oh, yeah. For sure. Okay. How we debug this? What do we need to do?
Well, I'd like to be helpful to figure out the layout of the stack when we enter this method. So maybe we could start a breakpoint at the start of the forwarding.
Yeah. Yeah, let's do that. Let's do that. I bet we're setting up, we're probably, we must be setting up the frame wrong. Where do we find the forwarding? Where would we find this? How do we break here? Ah, we can break in the, no, never mind. I was gonna say we could break at the send forward instruction, but that's not where it's messing up. It's messing up on entry to this guy. So it's like, as we enter this method, the stack is set up incorrectly. I think we can find that information. There's a place we have to know this.
Well, we could a convenient place might be, so send forward is its own special instruction, right?
Yeah.
Can we set a breakpoint at the end of it, like when we were just about to?
But there's no send forward instruction in this example.
Oh, right. We're just entering the
Yeah, this is
method.
A normal send. We got a normal send instruction here. We got to find that. We got to find the place that does the frame push, I think. And there's like a, I'm pretty sure there's an if statement for this. Forwardable, that's not helpful.
Yeah, star.c. Grab inside star.c.
Compile C. VM. Probably VM INS and helper. Yeah. Gotta be this one. Let's see. Call ISEC setup. Yeah, it's gotta be here.
I did see call.
No, not here.
Call ISEC forwardable was a method.
It's this one. It's called ISEC forward setup. So we're asserting, when we enter this function, we assert that the ISEQ that we're entering into is a forwardable ISEQ. So it's gotta be in here. You just set a breakpoint in here and see what our stack looks like.
Yeah.
Okay. LDB, mini Ruby, SRV, and then we'll do B here, and then run. I should have built this with debugging. I did not. And then that. Okay, so we've broken here. So if we look at our EC, let's do P, EC, CFP, and we want to look at our, so EC stands for execution context. That's the Ruby VM that we're currently, or the instance of the VM that we're currently working with. CFP stands for control frame pointer, which is the current stack frame that we're looking at. And where we've made a breakpoint is before we enter that triple dot method. So we haven't quite entered it yet. We're getting ready to enter it.
Yeah, we're gonna massage our stack a little bit and then push a new frame.
Yes. So I want to look at the SP, which is our SP stands for stack pointer. So that's like the thing that's keeping track of where we're in the stack. So we want to take a look at what the values are in there. The stack is just a list. So I think we want to look at -1. Maybe. That looks right.
Yeah.
Oh, script. Let's get that.
7 is 3.
Yep. And our code was what? Our code was 2 bar 2 3. So this is not right. Let's look at what 0 is, because I'd expect the CI to be on the stack.
Okay.
Or maybe we haven't pushed the CI yet. I'm not sure. Let's check 0. It's probably just garbage. Oh no, yeah, that is just garbage. Method entry. -2 is going to be our 2. Yep. Okay. This looks fine. so far.
Mhm.
Okay. Should we just like keep going and check what our param size, local size is, make sure our math is correct?
Yeah.
Okay, so param size, p param size. Our param size is 1. That seems truthy because we're taking one parameter, this x. I mean, I guess it's actually 2 because of the triple dot, but I think that's okay. And then local size is going to be 2, maybe? Our local size is 2, so that's, we treat underscore x as a parameter, and triple dot is a local, I guess. Juan is asking -3 should be bar. That is correct. If I print that out, it'll be bar. Yeah, right there. Okay.
Before we've adjusted these up by CI-argc.
Yes.
Okay.
Yes. Okay, so our local size. Wait a minute. Calling CDCI, we should have calling. This is where we do the adjustment, right? Yeah. This seems right. P local size. Oh yeah. What did I do here? Variable not available. Oh no, it's been optimized out.
Yeah.
Okay. It's okay. Let's just step into Callie setup arg, I guess.
Yeah.
Okay. Seems good.
This is where we have to check for forwardable and we do extra things,
Yes.
I believe.
Yes. It is not simple. It is... Okay, here we go. Yep, forwardable. Yeah. Here we go. CI. If we're forwarding, we're not. That's the case for where we have to forward to a forward.
Okay. I'm not sure I follow.
That's the case where we're doing like... right here. So we have to do special stuff if we're forwarding to a forward.
Okay.
A forward.
Right.
Which this is not that. Let's see. CI markable, we don't care about that. Here we go. This is where we push. So right here, we're pushing the CI onto the stack. Okay. So that param size -1. Where is argv? How do we calculate argv? P argv. Let's check what argv is. Argv 0. That's our... Okay, so this argv must be pointed at the beginning of our...
Yeah.
The beginning of our stack. That's all the parameters we're passing in. That's not right.
Is it not?
I don't think so.
Okay. Because we probably wanted... Yeah, we probably wanted to set it here. It seems like param size is off by 1, right?
Yeah.
Like we're setting at position 5, which may or may not be... Well, I guess it's on the stack, so that's memory we have. But...
this is a garbage IMemo object. We don't care about this. Somebody just wrote this to the stack, and it happens to be here.
Yeah.
Yeah, this is where we want to write to, but our param size is just bogus. It's 5 for some reason. Okay.
Which it probably should be, if we want to write into 3,
should be 4.
We should expect it should have been 4 because -1.
Yep. Okay, so how are we calculating this param size? Let's check that. So, oh, probably don't want that. That's probably just wrong.
It wasn't +1 to be the other side of that -1?
I think I've changed around the bookkeeping a little bit in here, so there may be a bug. Okay. I think that's what we want.
Yeah.
Okay, let's try that. Stack rotate. Okay, that's fine. That's fine. So let's just do mini Ruby test.rb. Aye. Let's just LLDB into it. I should have done make LLDB. What is wrong here? Okay. So, yeah. I adjusted some of the bookkeeping on this branch, so I think like some of the bookkeeping is wrong. Let's have a null there. This is BT F what? So this argc is just bogus. 2551. Let's go take a look at that. Yeah.
Is this our push frame conditional?
Oh, base. This is calculating base pointer. Okay. I bet this is wrong.
Mm-hmm.
So let's fix that. Off by 1 error. Yes. Actually, is asking, it might be related to previously parsing as star ampersand. I think that's why I did this. Like, this is actually a cleanup, supposed to be a cleanup of the bookkeeping. In master, we have to like add 1 in all these different places, but since we're getting rid of that syntactic sugar, I think it should clean up our bookkeeping. It's just we still have those sitting around. Let's just do this. Run. Hey.
That's something. What's printed out is very odd.
Yes. I'd expect that to be like 3.
Oh, is that a packed CI?
I think it is. I bet it is.
So these call infos come in 2 forms. Aaron said it's a Ruby object, but one of the kinds of Ruby objects it can be is an integer. There's a lot of the calls, actually, like almost any call that's simple, like doesn't have keyword arguments or things like that, we're able to just represent much more simply as this is a method that takes 5 arguments.
But that's weird though, because like, it's
well,
weird.
But
it's weird.
This is where we expect it to be, right? Like we're calling into this, and we haven't moved around the values to be in the order they need to be.
Yeah, but in this case, so I'd expect that underscore x is going to be like based on our stack layout, right? I'd expect underscore x is going to be -2 from the EP, and then I'd expect that our CI is going to be -1 from the EP. So I don't expect the CI to be printed out in this case. I think that we're off by 1 on the stack pointer in the callee frame.
Okay.
Like when we set up the frame for the callee, I think the stack pointer is wrong. Which is that argc that we were looking at. Let's find where we changed this. It's this guy. It's gotta be but that's why it's gotta be this. Calling argc, it's gotta be this -1. We gotta move that there. I think that's right. That's gotta be it. Oh, come on. Oh, no. This is right. No, it's not. Stack consistency error. Oh my gosh. Oh no. Okay. It's definitely not this. All right. What can we do? How do we fix this? How do we find the problem?
I still think we want to find a way to get a breakpoint after we've entered the method.
Yeah, we need to figure out how to get a breakpoint after we've pushed the frame on, so we can verify that the stack frame layout is correct. How can we do that? Like, we want to get into this isect normal call here that sets up the frame, but we want to make sure that we only do it in the case that we're dealing with the triple dot, right? Like when we've entered the triple dot. I guess we can just step. Let's just step.
Yeah, we could probably just step.
Yeah, let's do that. Make LDB, like, because we had that previous breakpoint that was like, let's see, Control RB, here, right?
Mm-hmm. And we could run up to here, and then we could set another breakpoint, or we could just step, or we could set a breakpoint on VM push frame.
Yeah, let's do that. B VM push frame.
B.
Yeah. Thank you. B, and then we just do continue, and then great, we're here. Mm-hmm. And actually, I think we got the SP. Like, I think the SP is passed into us here, so we can check.
Yeah.
Drew is saying there are only 2 hard things in computer science: cache, invalidation, naming things, and off by 1 errors. Yes, we might be off by 2 though. I'm not sure.
Mm-hmm.
If you're off by 2, is that off by 1? Off by 1?
No, you're just when you're off by 2, you're just off by 1 in both directions.
Okay, so I think SP is passed in here. So if we look at this SP, we can check if it's correct. Because, like, actually, let's go look at VM push frame for a sec.
Mm-hmm.
I think this is useful. Actually, we need. I gotta quit soon here. I got a meeting. Let's see. SP, blah 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 blah. So this is for. It could be this.
Oh, setting it to nil.
Because we have to initialize all the local variables to nil, right?
Yes.
And we're treating triple dot as a local variable, so we need to make sure that local size is 0 in this case. Like, it better be 0.
I don't think we were seeing that though.
No, we weren't. We definitely weren't. But we need to stop. Actually, yeah, I think SP is good. I want us to stop execution right here after we initialize locals.
We could probably just step to that.
I thought I did. What's going on here?
Do you have optimizations on?
Yeah.
Yeah, it'll probably jump around a little bit here. Because the compiler can reorder all of these however it wants.
Oh goodness. I think we're in the wrong place. This does not seem right. Yeah, let's try this again.
Okay.
No, let's do run. Actually, we gotta quit. Yes. Quit. Yes. LDB. Let's do our first breakpoint. Not on push frame here. Run. And then VM push frame here. And then we'll continue until we get to push frame. Why did it do that when I hit N?
I think it's probably like inlined push frame and reordered a bunch of things. Probably have to rebuild with debugging.
We don't have enough time for that. Let's break on this. Can we break on this line? What line is this? 402. Okay. Let's do that. Quit. We're gonna try one more thing. I really want to break on that line, and then we gotta quit. Shit. Oops. Oh, this is live. Try not to curse on my live stream here. Okay, run. And then we want to be VM ins and helper.c line 402. C. There we go. Let's check our SP. PSP 0 -1 ought to be. This ought to be our CI. This ought to be our CI. Sure. -2. This does not seem right at all. 3. There's our number 3.
Yeah.
We're off by 2 at least. Like, I'd expect like -3 to be what the value that we have at -3. I'd expect that to be the top of our stack right now.
Yeah. Do we have any? Are there any hints as to what we expected our CI to be?
That's gotta be the right. I guarantee that's the right CI.
Which one?
The one that's in the stack. Like that's the correct one for sure.
This one or this one?
Oh.
Like we have two.
We have two
integers.
numbers.
Yeah.
All right, I'm late to a meeting. We're gonna quit now.
Okay.
I'm gonna bring you back on. Okay.
Yeah.
Thank you for John. Thank you so much for walking me through this through this disastrous code. I really appreciate it.
Mm-hmm. We'll get it next time.
Yes, next time. All right. Thank you. I'm going to go back to the slides now. Let's see. Thank you, everybody. Thank you all for joining me. Let's go to the keynote. All right. Thank you. Thank you all. Next time, I'm going to try to do September 13th. We are excited for Rails 8. I'm always excited for Rails 8 until the next version, which I'll be excited for Rails 9. Oh, I went backwards. Welcome, John. Yeah, next time I'm going to try to do September 13th. So I'll schedule that in the live stream. Let's see, where the heck is OBS? Thank you all for coming. I really appreciate it. Hopefully we'll get this fixed up before Ruby 3.4 release, because I'd like to get these method missing things sped up. So thank you all. And if you have any ideas or suggestions of stuff you'd like to see in the future, leave a comment, send me an email, whatever you want to do. Reach out to me on any social media platform, and I'm happy to oblige. So thank you all so much. See you next time.